All right, so here we are. We are doing 10.2, and this is solving the equation. Okay, so how do you actually solve equations of this form? ax plus b equals c. And so in our previous video, we learned some vocabulary. Okay, this number in front of the x, that tells you how many splats there are. Okay, that's called the coefficient. And this b right here, this extra, this 1, is going to be the constant. Okay, and this is finally our answer. Okay, so this is an equation. And we're going to need to solve for whatever this variable here is. It's the unknown. Okay, it is the question mark. Okay, so let's start with an example. Okay, so I have negative 17 equals 3k plus 4. Okay, so we got example 1. So when we're solving these equations mathematically, okay, the visualization I showed you in the previous one, mathematically there's kind of, when you visualize it, you kind of understand why you're doing what you're doing, okay? But if we want to get up steps, the first thing that I want to do, and my whole job when I'm solving equations, is to isolate the variable. Okay, I need to get this variable, this unknown, by itself on this side. Because if I look at this equal sign, it's like two fields. Okay, and I need to move everything else on the other side so we just have the k by itself. Otherwise, I won't be able to figure out just what k is. So that's my first job. To do this, my first step, okay, would be to get rid of the constants. And by that, I mean these extras, these ones, okay? The ones that are not attached to a variable, okay? These guys, if you notice, this 3 and this k, they have a really good bond, okay? They're like Velcro, okay? They're attached to each other. But this 4, it's kind of hanging out, all right? It's very persuasive. We're going to persuade him to go to the other side of the field, okay? And how we're going to do that is if we notice opposite operations get rid of numbers. Okay, so when we thought about a scale, if I have 4 apples on a scale, to get rid of them, I have to take away 4 apples. So if I'm adding 4 apples, to get rid of them, I have to take away. Versus, let's say I double the number of apples. Okay, to get rid of it, I have to take away those 2 groups of apples that I just added, okay? Or I'm splitting or dividing those 2 groups out of it. So when we look at opposite operations, adding and subtracting are opposite to each other, and multiplying and dividing are opposite to each other. So right now when we look at this, this is a plus 4. So to get rid of it on this side completely, we need to subtract 4. Plus 4 minus 4 gives me 0. Oh, perfect. I got rid of that 4 on this side. But like we learned in a scale, if I take away 4 apples from one side of the scale, it's going to be unbalanced. So I have to take away 4 apples from the other side of the scale as well. So what I do to one side, I have to do to the other. So now, negative 17 and negative 4 is going to give us negative 21. It's going to be equal to, and then all we have left here now is the 3k. So I always rewrite my equation. Okay, now this is the new equation I'm working with. It's brand new, and this is similar to what we did last week. This is 10.1. Okay, so now I have to un-Velcro the k. Okay, I have to get rid of this k. I got to separate these two. Well, how are they attached? How are these two numbers attached? They're attached using multiplication. This is 3 times k. So if I know 3 times k is going to give me 21, how do I get rid of this 3? Well, we use the opposite operation, which is division, okay? So we're going to divide by 3. When I do that, and we divide this side by 3, what's 3 divided by 3? What is that going to give us? That's going to give us 1. So what we're left with on this side, what we just did, we found out what 1k was. All right, we managed to get it down to 1K, which is exactly what we need. We just want to figure out how much is under one splat, not under 3 splats. How much is under 1 splat? Okay, we have to go that further step. So that's what we just did here. Okay, we split those negative 21 dots, okay, that are underneath 3 splats. We figured out how many are under 1 splat. And to do that, we had to divide both sides by 3. 21 divided by 3 is going to be 7, and a negative divided by positive is going to be negative. And so 1 splat, or K, okay, 1K is going to be negative 7. Okay, and that's how we were able to do it using opposite operations. Okay, and so let's check our work though. Okay, and this is, I keep telling people, this is the best part of this chapter, is you can always check if your answer is right. You don't have to wait for me to mark anything. You can check every single answer that you do. So if I rewrite this equation that we just did, negative 17 equals 3K plus 4, we just found that K is equal to negative 7. Okay, so let's check to make sure, is that going to work? So what happens is that we need to put K, we need to put a negative 7 in place of K. So we're going to rewrite this equation. Negative 7 equals 3 times, and what was K? Oh, it was negative 7. Don't forget that negative. Don't get it confused. Plus 4. Okay, now let's solve through. 3 times negative 7 is going to be negative 21. And I rewrite my whole equation again, just like when we use BEDMAS. Okay, remember when we did BEDMAS equation, we would rewrite it every step of the way. Okay, I encourage you to do the same thing when we're solving equations. Okay, it's very important. So now we got negative 17 equals negative 21 plus 4. Well, let's see what this equals. Negative 21 plus 4. I'm at negative 21 degrees, and it gets warmer by 4. Now I'm at negative 17 degrees, which is the same on both sides. So we did it correctly. If, for example, it was supposed to be negative 17 and I ended up with negative 7, this is not right, which means the way that you solved that K would be incorrect. Okay, so that would tell you that you did not get a correct K. Okay, and that's how you're able to check your work solving equations of this type. Okay, so let's just review our steps. All right, I'll give us a fresh equation just to review what we would do. So let's say I have 8x minus 7 equals negative 31. I think you're all noticing you need those integer rules. It's pretty important. So the first step that I have to do to isolate the variable is I got to get rid of my constants, okay? Those extras, those ones, okay? Those little blue dots that are not underneath the spot. We got to get rid of them, okay? To get rid of this one, though, I'm adding 7. So I'm subtracting 7, so I would add 7, okay? Because I'm using the opposite operation. Right, so that's my first step. But what I do to one side, I do to the other. Okay, super important. So if I'm adding 7 to one side, I'm adding 7 to the other side. And then rewrite your equation. So now my new equation is going to be AX is equal to negative 31 plus 7 is going to be negative 24. Okay. And then here we go again. So now my second step is going to be separate x from the coefficient. Okay, separate that x from the number that it's attached to. Okay, x is attached to a right now. They're like Velcro. We got to separate them using opposite operations. The beauty of opposite operations. So when we do that, this is 8 times x. Okay, so this times, what's the opposite operation? Divide. 8 divided by 8 is 1. Great. We got rid of it over here. what we do to one side, we have to do to the other. So if we divide by 8 on one side, we have to divide by 8 on the other. And then again, rewrite the equation. Everything that you're doing should make sense, okay? So I'm writing these notes for you because they're supposed to help you out. 1x is equal to negative 24 divided by 8, which is going to give us negative 3, okay? And that's our answer. So everything that I'm doing, all these steps, right, I'm writing them out so you can kind of get into a rhythm. And this is why I love solving equations, because once you kind of get into a rhythm, it's so much easier, all right? Because it's step by step by step. You do the same thing every time. It's really nice that way. That's something that I enjoy. But every single thing that we did here has a purpose. Okay, so getting rid of my constants, okay, that's because when we visualize those blue dots, that's what we did, right? When we were looking at these separate blue dots and we were trying to figure out, okay, if there's 5 total, we don't know how many are under the x here, but I take away these 2 extras. Well, we always went, okay, 5 minus 2 is going to tell me what's left underneath the splat. It's going to tell me what's underneath that big black splat. So that's exactly what we're doing here. We got to get rid of the constants, get rid of those extra blue dots that aren't underneath the splats, okay? And we do that using that opposite operation. Then the second thing is now we're figuring out, okay, now we have to separate the x from a coefficient. Well, we have, 8 splats with 21 blue dots, okay? How many blue dots are in each splat? Well, we have to divide 21 dots between 8 different splats, which is exactly what we did here, okay? This opposite operations thing is logical, okay? It all makes sense why we're doing it. And that's why I showed you kind of, 8 divided by 8 gives us 1. That's why it works. That's how you get rid of it, okay? Mathematically it works, visually it works. That's why we're doing it, okay? And if you're able to understand those, then going forward, you can use these steps, okay, that I will always add to every time you learn something new to help you solve equations of this type.